In this video, let's understand SDT for evaluation of expression. Okay, now in previous unit, that is unit 2, we have already seen syntax analysis wherein we make use of context-free grammar. If given an expression, just to check whether that expression is valid or not, okay, what we do is we check whether that string can be derived from that grammar or not. Okay, so if I give you all any arithmetic expression, computation of the actual value, actual result does not come into picture in the parsing phase, that is syntax analysis phase. So we make use of certain rules, that is semantic rules, in order to compute the value, okay, and that value can be computed by means of the semantic actions associated with each of the grammar productions. Okay, so let's take the expression grammar. E gives E plus T, E gives T, T gives T into F, T gives F, and finally F gives ID. Okay, so if we'll define some semantic actions with each of this grammar rules. So I write semantic rule as E dot val is equal to E1 dot val plus T dot val. Then over here I write E dot val is equal to T dot val. T dot val is equal to T1 dot value into F dot value. For this it is T dot val is equal to F dot value, and finally F gives ID is F dot value is equal to ID dot value. Okay, so let's take one simple expression. Say if I give 1 plus 2 into 3. Checking whether syntactically, structurally this statement is correct or not. Okay, how do we check? We try to derive this string using this grammar. Now I want to compute the actual value of this expression, that is 3 into 2, 6 plus 1. I should get value as 7. Okay, so what we do is, along with this grammar rule, we incorporate some of the semantic rules, okay, in order to compute this value. Okay, so given any SDT, okay, so or if you want to write SDT, given any expression, what we do is we draw a parse tree for that expression using this grammar. Okay, so I'll draw a parse tree as E gives E plus T. So I start with the first production, E gives E plus T. Then I substitute for this E as say T, then T gives F, and finally F gives ID. Okay, over here in place of T, I'll substitute T into F. Again for this T, I'll substitute F. For this F, I'll substitute ID, and for this F, I'll substitute ID. Okay, so I have derived this string. Okay, structurally I have got this, that is ID plus ID into ID. But corresponding to each of this ID, there are some values this time. Okay, so this ID is 1, this ID is 2, and this ID is 3. Okay, now let's see how to convert, how to get this value using this SDT which is defined here. Okay, so if you get just one ID, okay, if there is reduction procedure, when you traverse this tree from top to down, left to right, on the way, if you encounter any reductions, you apply the semantic action associated with that rule. Okay, so I start from this point, I traverse this tree from top to down, left to right. So when I reach at this point, that is at F here, F gives ID. So just check if in grammar rule there is a rule which gives F gives ID. So this is reduction, right? So what is the action associated with this? What should happen over here if you get ID? Since I've got this 1, that is this number, what we do is we just assign this value, that is 1, to F. That is, we propagate this value on top. Okay, so 1 which was present here, okay, is propagated at top. Okay, so F dot value is attribute associated with this non-terminal. So the action is F dot val is equal to ID dot val. What is ID dot value over here? The actual value is 1. So that 1 is propagated at F. Now again go on top. T gives F. Okay, is there any grammar rule in your grammar which gives you T gives F? Yes. So again, what is the action associated with this? Whatever value is there in F dot val, that value is propagated on top, and the attribute for t dot value is equal to whatever value was there in f, so that is 1. Okay, so t dot val is equal to 1. So this value is propagated on top. Again go on top, you encounter E. Is there any production which gives E gives T, E gives T? Yes, there is a grammar rule which gives E gives T. So again over here, whatever value is there in T, that value is propagated on top, that is to E. Okay, so over here the attribute will be E dot val is equal to T dot val. What is there in T dot val? What is the value? It is 1. So 1 is passed here. Okay, then we are at this point. Again come down. When you encounter, there is no reduction because there is no production which gives you E, T, F and plus. Okay, right now we are on the way. Go on top, again come down to this point, and you will encounter this ID F. F gives ID. What is the ID value over here? The actual value, it is 2. So over here F gives ID. Apply this action. F dot val is equal to ID dot val. So F dot val is equal to ID. What is the ID value? It is 2. Go on top, you encounter this T. T gives F. So T gives F. T dot val is equal to F dot val. So whatever was there at F, F dot val, pass that same value to T. So 2 is passed over here. Come on top, you don't encounter any reduction. Come again, come down to this ID, you encounter this 3. When you reach at this F, F gives ID. So again apply the same rule. That is, you pass this ID to F. So I pass this value 3. Then when you get at this point, when you reach at this point, okay, when you have traversed, T gives T into F. So is there any rule when you reach at this point, okay, at the right hand side, you get this rule as T gives T into F. So just check if there is any grammar rule which gives you T gives T into F. Yes, there is. Yes. So at this point, what is the action associated with this production? It is T dot val. So that is, I am computing T dot val is equal to T1 dot val is the expression, is the value which is there on the left hand side. What is T1 dot value? What is the value associated with this T dot val? It is 2. Into what is the value associated with F here, which has been propagated? It is 3. So T dot value at this point will be equal to 3 into 2, that is 6. Fine. Now we are at this point. So again go on top, and when you reach at E, just check if there is any rule which states E gives E plus T. E gives E plus T. Yes, there is one rule. What is the action associated with this rule? It is E dot value, that is E dot value is equal to E1 dot value. What is E1 dot value? Which value has been propagated here? It is 1, right? So E1 dot value is 1 plus, what is T dot val? What is T dot val? The latest value, it is 6. Compute 1 plus 6, which gives you 7. This is how SDT for arithmetic expression is applied in order to get this final value, that is 7.